Good morning, everyone. My name is Shubham Kaushal, and today I'm going to present to you the cryptography practical visualization of security attacks. So first, we'll be starting with our first task, which is the Caesar cipher. Here, we'll be talking about how we'll be using Caesar cipher to convert plain text into ciphertext. So here, in this example, as you can see, we have a complete message that has been converted into ciphertext by using a key which is basically 3. So we will be adding each and every number by each and every letter by 3. So here, as you can see, we have cryptography is the practice of secure. The entire message is here, and it will keep on increasing by 3. So that is the output that you get here. And if you just use this frequency test, which I'll be explaining later, you can decrypt the ciphertext into plain text again, as you can see here. So now I'll explain how the frequency analysis breaks the cipher. So as we know that here, as we've written, frequency analysis breaks the Caesar cipher because the cipher only shifts letters. Basically, the cipher will only shift the letters like uh, by 3 or 5 or whatever. So it will only shift the letters, the frequency will still remain the same. As we know, E is the most frequently used letter, it appears the most. So by checking which letter appears the most, we can figure it out. So by using brute force attacks, Caesar ciphers can be figured out. So they're not the best method for cryptography. Now, the second point, the second task, we'll be talking about AES and the avalanche effect. So here, as you can see, we have the AES cipher. Here I've written my registration number, which is 24270308824. Now I'll play, and here you can see the output. We have a huge output here. Now if I change even one number or one digit here, the entire output changes. This is basically the crux of avalanche effect, which I'll be explaining further. The avalanche effect means that even a small change in input, like changing one letter, one bit, one number, it can change the entire output in AES, because as we know, in AES we have multiple steps. We have sub bytes, we have shift rows, we have mix columns, add round key. There are a lot of steps. So even if you change a single bit, it will change everything else. So here I have shown the entire process of AES cipher and the avalanche effect. Now I'll be moving to the task 3, which is RSA encryption. Now I'll be explaining to you what RSA is. So first I'll be showing you the example here, RSA encryption. Here we'll be using two prime numbers, and these prime numbers will be used to generate the keys. And for encryption we'll have a public key, and for decryption we'll have a private key. So anyone can encrypt the message, but only the person with the private key can decrypt the message. That is the basic crux of RSA. As you can see, then the sender encrypts the message using the receiver's public key. The encrypted message becomes unreadable ciphertext. Now I'll be moving on to the task 4, which is password security. Password security, I'll be showing you the example here. As you can see, this is RSA encryption, this is RSA decryption, where I'll be using the private key, and you can see we get a final output. Now for password generation, as you can see here, I have given a password, and I'll be showing you how a small change can affect the password. As you can see, my password is not strong right now, but the moment I add more details to it, the bit strength increases, and it will keep on increasing if I keep on adding more uh, more numbers or more characters. And now I'll be discussing the question that has been asked, that is explain bit strength versus brute force attacks. So bit strength is basically, it measures or how strong a password is and how many types of combinations it can have. Higher the bit strength means more possible combinations the password can have. And for the brute force time, basically it is the time a computer will take to like to guess the password, or like the possible combinations of the password. So it will be the time that it will take to decrypt the message. So here I've discussed all the tasks here, and as you can see we have shown all the possible outcomes here. And with this I would like to end my video. Thank you.